Okay, so our next presentation will be co-presented by John Pressley and Dylan Lustig from the Duke Energy Corporation, headquartered in Charlotte, North Carolina. So John is a Director of Information Management Solutions with Digital Transformation Team, and Dylan is a lead analyst with the Digital Transformation Group. So I think they'll be going one at a time, and John's already up on the main stage here, so I will get out of the way. John, feel free to take it away.
The slides up. All right. So hopefully everybody can see that. And so, as introduced, I'm John Pressley, and we're with Duke Energy, and so not to be confused with Duke University. And we're based out of Charlotte, North Carolina. And, I wanted to take a second and say thank y'all for being here at 4 o'clock on the first day and attending this session. And I want to thank Duke University for this symposium and pushing the needle on some of the hardest topics within the energy industry, which is data and analytics and data science, and pushing the needle to move faster. And I think that data science is the force multiplier to do such a thing. And in my area, the things that we work on is really twofold. And so digital transformation is actually kind of carved out of IT. It's aligned to no single line of business. And so we're able to work across the boundaries. And my peers and I, we work on things like operational excellence and the customer journey. And what I work on is around the grid and the DERs and the electric vehicles, et cetera, to help move the needle within the company and create new products. And I also have responsibility for data. We centralize all the data at the company, from finance to HR and supply chain. And then we have lots of tools to curate it, govern it, visualize it, create analytics from it. And that's why we have these great products that we've built. I'm here with Dylan Lustig, and I don't know if you can jump on and say hello.
So yeah, hey everybody, my name is Dylan Lustig. I'm an analyst in our digital transformation group. Been helping solve some of these problems for the last 5 years, and it's been a great journey so far. So happy to be here. Thanks for having us.
All right. So we're going to talk about digital transformation. We're going to talk about the problem set, and then we're going to talk about some of the use cases that have been able to be leveraged by the data and the data science and the application development. So let's keep going. So why do we need to have a change in terms of digital and data science, et cetera? And the reason is we have a lot of new technologies coming at us from all directions, right? Solar and batteries, wind, and customer programs like demand response, electric vehicles, et cetera. And to be able to adopt these new technologies, we need to have something that's going to be able to make that technology get adapted to our grid and to the industry quicker. And for me, I think it's the digital technologies that are the force multiplier. And so using data science and data and technology is far faster than trying to deploy millions of devices or hundreds of thousands of devices in the physical world. Then it takes years to deploy that kind of technology. Whereas deploying code and having updates and providing more value can be hours or days away in the digital world. All right, so the next slide, really pulling it all together. I think today, a lot of the things that you will have seen, all the way from Dr. Paris to just our last ones, is talking about how do we balance the grid. This problem is a real problem, and it exists across many different facets. And if you think about this in a large company like Duke, this is, 15, 20, 30 different departments that are impacted, whether it's operations or the grid or customer programs. And without coordination and without technology, it becomes very difficult to be able to have a cohesive solution. And part of that is the IoT solution. We need a way to communicate securely and in real time, or at least near real time, to help trigger how many amps do we give the EV car? And, do we curtail solar? Do we turn off your pool pump? How do we coordinate and not just set generalized rules like, hey, at 11:30 tonight, you need to start charging your car, which is not a great user experience, but it also just pushes the peak to 11:30 at night. And so having technology and having communication and real-time information, and then do we have enough intelligence at the edge, in the devices, to make decisions? Because we just, think about the phone operator. Everybody would be a phone operator if we didn't apply digital technology to that problem. So how do we apply technology? And so the next slide, we talk about our investment isn't just in technology. Our investment was into people. And the people make the great products, right? We have invested in the new technologies of today, but we've also invested in people. So design thinking, human-centric design. How do we find a way to move faster, like agile? And, UX design so that it is a user-centric interaction. But really what we found out that those were very short sprints. Where the real work was in the data. 70% of all the work shows up in the data. And so cleaning that data and creating insights from that data, we've invested heavily into data science. We practically have a data scientist on every single one of our products, and we have over 100 products. So we've invested heavily in that, but we've started to use data science as a means to cleaning up the data, as opposed to rolling trucks and having people inspect. And so great people need a great framework. And so the next slide kind of shows you how we take that human-centric design to try to fall in love with the problem, not the solution, right? Hey, I got this great tech, and let me show you how it's going to make your life greater. It's more about what is the problem and how do we reverse engineer a solution, bend technology to the problem. And a lot of times that means we have to build it as opposed to buy it. And we've invested in people that are mobile app developers, API, machine learning, everything in between, deep learning. We've done drones and drone analytics. We've hit a lot of major places to create value that the business and the customers need. And that's really kind of the journey we've been on for the last 4 or 5 years. And so Dylan's going to talk about that journey a little bit more in depth.
Yeah, thanks, John. Just want to make sure everyone can still hear me. Good?
I can.
Oh, perfect. Put that up. All right. Yeah, so, thanks, John, for that. I think it paints a pretty good picture of, where we started, right? We knew that we have all of this data, right? This meter data, which gives us voltage and usage. We have pi data in the form of, sensor data. We've got all of this data that Duke had the foresight to say, hey, we need a mechanism to be able to gain insights from that data, right? And that was really the inception of our open analytics platform. And so, we've been able to utilize data science to derive insights from massive amounts of data, which today utilizes thousands of cores of CPU to ingest and crunch meter usage and meter voltage data at the tune of 5-minute intervals. And so, that compared with our plant information data, our sensor data, right? We're ingesting about 1 to 1.5 terabytes of data per day. And so our total utilization right now is somewhere about 4.8 petabytes of total data that our data scientists have access to, right? And so it's a cool thing to be able to look back and say that, our first use case, which really drove the establishment of this platform, it was called revenue protection, really led to something that was much greater, right? And that is the centralization of meter data and the practice of applying AI and machine learning to this data set. So, revenue protection was a huge success, right? We were able to use AI and machine learning to detect instances of theft, as well as meters that may be misconfigured or had been tampered with, or that just flat out were not working, right? They were not performant. And our data science team really succeeded by unlocking more value through this one use case than it took to, the actual cost to build the platform. And so this one use case, right, if we look retroactively, it created something really cool. And that was the freedom for data scientists to explore ways to utilize our data to not only bring value to our company, but to bring value to the way that we operate the grid and the way that we're able to deliver solutions for our customers, which is ultimately, that's why we're here, right? We're here for our customer. And it's that freedom today that's enabling our company and data science specifically to become part of the industry's transformation. And so we'll move on here. You can see, right, tying back to what John was talking about, when we apply data science in our digital framework to the most complex problems, we can accomplish some amazing things, right? And we're not just talking about some of these big problems that the industry has recognized over the last 5-10 years. We're actually digging in and solving some of these problems. And thanks to our open analytics platform, our data scientists have been they've been able to enable solutions that use IoT, right? Like our smart meter usage app, right? That allow us to maximize the efficiency of our solar operations by ingesting Pi data, that have provided useful insights into what's happening at the most discrete level of our grid so that we can do things like forecast better than we've ever been able to forecast in the past. And also, validate and fix some mapping relationships for grid assets that we have, right? And customer meters. And finally, that give our large accounts the ability to understand their carbon emission footprint. And so, it's been an extraordinary journey, as you can tell. We've had a blast over the last 5 years. And John said, right, we've got over 100 products now. And when you look across that portfolio, you see a lot of data science. But we are constantly looking for top-tier elite data scientists to come in and help make a difference for Duke and for our customers. And so, we appreciate being here. We appreciate, the support that we've always gotten from Duke University. And certainly the good work will continue, right? We've got a lot of work left to do.
So with that, we'll jump into the Q&A. So first question on deck. What data do you have the most difficulty getting, even with the abundance of data you have? So for example, certain aspects of customer usage data, current infrastructure info, or others?
We have access to a lot of data, and there are obviously things that haven't reached the modern age and are not generating data, right? So there might be reclosers that are still quote unquote dumb, but the real issue isn't getting access to data. It's having clean data. Things don't always work. Sensors don't always sense. Data, fails to get to where it's supposed to go. And so you might have missing or incorrect data. And then when you look at that problem in volume, when you're talking about billions of rows, finding that needle is hard. And so it's just a volume of data that's really the problem. And then getting access to it, with any large company, getting access to someone else's data is always a chore. But luckily, we are in the data domain, and we are very tuned in with our data stewards and data owners, so that part makes it a little bit easier.
So I had a very similar question, so I'll build on that just a little bit. So essentially your models, are they designed in a way that they can take almost any subset of inputs, or do you place some constraints on, everyone in this area has to have meters or something, or sensors that sort of provide the full matrix of data for your models to run?
Yeah, so for instance, meter data, of the 7.5 million meters that we have, there is some small percentage, although very small, of people have still the dumb AMR, or it just sends data once a month. And so we have to use proxy techniques, houses of this size or houses in this neighborhood, generally with a total kilowatt for that month, are equivalent to a house. And so you have to use proxy data to get around it. But there's a bunch of different techniques that the data scientists use to overcome data. And as I was saying earlier, we've been using data science to clean up the data, which has been the most exciting thing for me, because we spend lots of money sending and auditing. Humans going out and auditing still don't get 100% because it's a human doing it. Whereas with data science, we can get anywhere in the 90s to the high 90s without sending humans, and then validate things that drop out with, so if you have 100,000 things to go look at, now you can only send a truck. Now you might only have to send a truck to a couple hundred. So it's a major cost savings.
Got it. Excellent. So the next question, let's see. So this is a good one. So for a student still getting into data sciences, or one like me who's been there for a while, what sort of education and experience would you recommend for learning how to clean up data?
Python is king, right? Yeah, some SQL is also king, right? A lot of SQL out there, but Python and Spark are good things to know to cleaning up data. And honestly, the things that are the most intangible are the things that we're in greatest desire for. It's people that can connect dots and get people into a room and figure out what the answer is, whether it's their answer or someone else's. I'd much rather invest in someone who knows how to work with a team and solve problems and come up with the best answer for Duke, as opposed to themselves. And because otherwise you can teach people anything. But obviously if you know Python and Spark and all the regular tools like Java, et cetera, those things will help you.
Okay, great. Thanks for the feedback there, both for the question asker, and I added a bit there myself, so that was helpful. Thank you. So everybody, thanks Dylan and John for an excellent presentation and insightful responses to the questions.